Okay, question 2 from tutorial 5. So milk with a density of 1020 kg per meter cube is transported on a level road, and tanker length given 9 meter long and 3 meter diameter cylindrical tanker. Now tanker is completely filled, so completely filled with the milk, no air space. So there will be no air space inside the tanker. It's completely filled. And it's accelerate at a 4 meter per second square. So constant acceleration is given as a 4 meter per second square. Now, if the minimum pressure in the tank is 100 kilopascal, now determine the maximum pressure difference and the location of maximum pressure difference. So here they give us the minimum pressure. So if we can find out the maximum pressure, then if you find out the difference between maximum pressure minus minimum pressure, so it will give you the maximum pressure difference. So we'll find out this one. And okay, then so we'll solve this question. So your milk is transported, so substance is milk density is given, and acceleration also given, and we need to find out the maximum pressure difference. So we'll consider acceleration will remain the constant, and the milk is an incompressive substance, and density of milk will use the given one, 1020 kg per meter square. So first we will define the axis. So if you define, say, this point, say here the origin, and say along the length is, I can use the green one. Let me check. Say if I use the green color, so if you can see the position, say this one will be the, no, I think the green one is fine. So from here is a x-axis, and in vertical direction, say z-axis, and this location is 0 0 for z and x. So length given 9 meter, height given 3 meter. So acceleration, if you see the motion is traveling in this direction, so acceleration will be in this direction. So this one is along the x-axis, so you can write down as ax, and magnitude of acceleration given 4 meter per second square. Now we consider from this point is this way, x is positive, but acceleration in x in negative direction, so it will be the negative sign here. And there will be another 2, say for acceleration in downward direction, the gravitational acceleration, the z, and your truck is moving only in horizontal direction, and they already mentioned is a level road. Say is a level road, that means no inclined surface, the level load, and your magnitude of acceleration will be same as your acceleration for x component only. There will be no acceleration in az direction because no movement in z direction. So az, the acceleration z component will be 0. Now for if your liquid move like as a rigid body, so your motion as rigid body motion of a liquid with the linearly accelerating tanks. So if you go to the lecture note, you'll see there's so many explanation given what will happen if your particle or if your liquid move as a rigid body. Say for example, say this on your container, so if filled with any type of liquid, So this will be the free surface if it's statics. And then if we apply the motion, if try to start to move in, say for in this direction, so if similar to tank, say for move in this direction, so due to the movement, your liquid phase, it will be like spill like in this way. So now it will be your free surface because motion is this direction. So and it will happen like this, so we can find out this slope and all other things. But in this problem they mention the is here is a completely filled with milk, no air space. If completely filled, for this case it will not happen the similar case, because if say if you total volume is here is tanks, it completely filled, so it will not happen like this. But in general case, if it's a free surface, if there are gaps, so your milk so your liquid will move like this way. Now the due to this type of movement, there will be two type of pressure. Now if you want to find out the pressure difference, so there will be related to two. One will be the pressure difference due to the acceleration in the horizontal direction, and due to acceleration your liquid will push the force in the back wall. It will press a pressure on, put the pressure on the back wall, and your so pressure difference first part will be the resultant of acceleration in the horizontal direction and the resulting of compression effect towards the back of the tanker. And this one, if you write down, say for pressure difference between any 2 points, so it will be the negative density acceleration in the horizontal direction, say here ax, and the coordinate difference between 2 points. Say if you write down in terms of any point, 2 points, say for point 1 is here on the upper front corner, say another point, say point 2 here. Now if you want to find out the pressure difference between point 1 and 2, so we can write down like it will be the delta P or pressure 2 minus pressure 1, pressure difference between these 2 points. It will be equal to negative of the substance. So here the density of the liquid means here milk, and there will be acceleration in this horizontal direction. Then your coordinate difference, so your x2 minus x1. So it will give us the pressure difference between point 1 and 2 due to the acceleration and resulting of compressive effect on towards the back wall. There will be another pressure for rigid body motion of the liquid. This one is due to the hydrostatic pressure. So hydrostatic pressure basically the increase with the depth. So so it will depend on the depth of the fluid or liquid. So we can, if you write down the pressure difference due to the only hydrostatic pressure, is formula is negative density of the fluid, then your acceleration in the vertical direction. So vertical direction we consider the z. So acceleration in z component, or this one come from the motion and plus the gravitational acceleration, and it will be times the your coordinate difference between any 2 points, the z-axis coordinate. For example, same here, if you write down to pressure difference due to the hydrostatic pressure between point 2 and point 1, it will be negative, then density, then your gravitational acceleration plus az, then your z coordinate for point 2 minus z coordinate for point 1. This is for the general case, for you can apply for any problems, as long as if your liquid move like as a rigid body, there will be two type of pressure. Now if you want to find out the total pressure, so it will be summation of 1 and 2. So total pressure difference between 2 point, any 2 point, it can applicant for any 2 point in a incompressive fluid in a linear rigid body motion. So same as in our case, so it will be the total pressure difference, say for example between point 2 and point 1. Formula will be rho ax x2 minus x1 and minus z plus az plus z2 minus z1. This one is general. You can write down for any 2 points. For example, we use here point 1 and 2. Now, if we analyze this question, sorry, this equation, if you can see here, your density of fluid is constant, and your acceleration in x-axis also constant. We consider as a constant. Same thing here. Density will be liquid will be the constant. Gravitational acceleration constant. Your acceleration for our case here is it is 0, but for in general case, if not 0, but it will be the constant. So only we can see here only the the distance between 2 points in x-axis direction, in z-axis direction is variable. I mean, say for example, we select point 1 is here upper front and point B is a lower rear corner. So your x2 and x1 and z1, z2 will depend on these 2 points. If anyone select another point, say for here, say point 3. Now, if you want to find the pressure difference between 1 and 3, so we need to find out point 3 coordinate for x, for z. Same thing for if you want to calculate for the pressure difference between say this point, say point 4, we need to find out the coordinate for here, then z coordinate for this point. Then we can find out the difference between any 2 points. So we can see our pressure difference, it will depend on only coordinates. Now, so they mentioned find out the maximum pressure difference. So if your pressure is, if you can find out where will be the minimum pressure and where will be the maximum pressure, so we can find out the pressure difference based on the coordinate. Say for here we consider O is a 0, 0. Now for point 2, your x will be the same as length and z will be the 0 because on the x-axis. Now at point 1, your x will be the 0 on because of this point on the z-axis, and z will be 3. So for example, for point 3, say for point 3 is say for this corner. It will be easy for us to find, say point 3. So your x will be the 9 and z will be the 3. Right? Say for point 4, say at the centroid, say point 4 at the mid of your tankard. So here x will be the 4.5 and z will be the 1.5. Now, if you can see you for all case, so if you consider pressure difference between point 1 and 4, so only it will depend on the coordinate for x1, z1, x4, z4. If you use the any point, say 1 and 3, or 3 and 4, or 1 and 2, all will be depend on your difference between their coordinate. And you can see your, if you select the upper corner and the lower corner, you will get the more coordinate difference. Say for if you compare with the 1 and 2, your x will be the 9 x difference, so it will be the x difference will be the 9 and your z difference will be the -3. So negative here means for if you use the final point as a 2, initial point is a 1. So final point coordinate minus initial point coordinate. So it will give you the negative, just the downward direction. And you can see this difference will be the highest one, combination of with other all kind of 2 points. And they mention the minimum pressure is given. So we know the pressure will be there. The two type of pressure. One is due to the hydrostatic pressure, another due to the acceleration. So on the upper line, there will be no hydrostatic pressure because hydrostatic pressure depend on the height. So on this upper line, at any point, your pressure will be you only due to your hydrostatic pressure there will be zero pressure, and only it will depend on your horizontal direction movement related pressure. So part one. Yeah. So we can say that on the and say for point one, here your point one you have the hydrostatic pressure is a zero because on the top, and the relative pressure your acceleration will be lowest, but here it will be the same. So we can consider point one will be the minimum pressure location, and this one is given as a one, how much given, 100 kilopascal. And important one is the point two. At point two it will be the highest pressure. Now if you use point one and point two difference, we will get the maximum pressure difference, right? Because between point one and two your coordinate will be the highest difference. Here will be the 9 meter, here will be the 3 meter for all any other combination. So we can write down conclusion sentence. Your lowest pressure in the tank will occur at point one. Point one means upper front corner as we defined, and the highest pressure will be at the point two, the lower corner, rear corner, because of your pressure difference only depend on 2 point coordinate difference only, and we checked only point one and two they will have the maximum coordinate difference in x-axis and y-axis. So now if question mentioned one of them was the find out the location of maximum pressure or highest pressure, so highest pressure will be at point two, means lower rear corner. Second one was the find out the maximum pressure difference between 2 points. So we'll use the point two and point one because this one will be the highest one, this one will be the lowest one. So this will give us the minimum pressure difference. So formula, if you write down now in terms of it's already here, so negative rho ax, so x2 minus x1, then density z plus az plus z3 minus z1. Now here your density is given 1020 kg per meter cube. Ax in negative x-axis direction given is meter per second square, and already we find out the x2 x3 if I write here. So x1 will be the 0 meter, x2 is a 9 meter, and your say another one is density, and az will be 0 because no movement around the z direction. Z, sorry, it will be z2. Z2 was 0 and meter, and z1 is 3 meter. Now if you put the all values in this equation, if you put all values in this equation, it will be say 1020. If I take a common, negative 4, then difference between 2 will be the 9 minus this one is 0, so 9.81, and z2 minus z3 will be the negative 3. So negative will become positive here. So wait. So finally we'll get the, so if you take the negative here with the density, so it will be the positive, and here this one the difference between two coordinate. So finally we'll get the negative positive, here negative positive. If we solve them together, we will get the 66700 pascal pressure. So this one will be the maximum pressure due to the movement of the tank. Okay, so hope you understand the question too. So still, if you have any question, you can send us email or we can discuss in the tutorial class. See you in tutorial class.